Chandrayaan is a series of Indian lunar exploration missions conducted by the Indian Space Research Organisation (ISRO). The name, Chandrayaan, is derived from two Sanskrit words, Chandra, meaning moon, and Yaan, meaning vehicle or spacecraft. The primary objective of these missions is to explore the moon's surface, study its geology, and conduct various scientific experiments. Chandrayaan 1. Chandrayaan 1 was the first mission in the series and was launched on October 22, 2008, using a Polar Satellite Launch Vehicle (PSLV-C-11). The spacecraft carried a suite of scientific instruments, including a high-resolution remote sensing camera, a spectrometer, a radar mapper, and a Moon Mineralogy Mapper (M3) from NASA. It also carried a small impact probe called Moon Impact Probe (MIP), which was released and intentionally crash-landed on the Moon's surface to study the lunar soil. Chandrayaan 1 operated successfully for almost 10 months, and in November 2008, it discovered water molecules on the Moon's surface. Unfortunately, the mission suffered communication loss on August 29, 2009, and eventually, ISRO declared it lost. Chandrayaan 2. Chandrayaan 2 is the second mission in the series and is an ambitious project aimed at exploring not only the Moon's surface but also its subsurface. The mission consists of an orbiter, a lander called Vikram, and a rover named Pragyan. The Chandrayaan 2 mission was launched on July 22, 2019, on board a GSLV Mach 3 M1 rocket. After a series of maneuvers and orbital adjustments, the spacecraft successfully entered lunar orbit on August 20, 2019. The lander Vikram separated from the orbiter and attempted a soft landing near the lunar south pole on September 6, 2019. Unfortunately, during the final descent phase, the lander lost communication with the mission control, and the planned soft landing was not achieved. As a result, the status of the lander and the rover's condition remained uncertain. Despite the partial success of Chandrayaan 2, the orbiter remains fully functional and continues to orbit the Moon, performing various scientific observations and experiments. It carries several payloads, including cameras, spectrometers, and a dual-frequency synthetic aperture radar (SA), to study the lunar surface, mineralogy, and water-ice distribution. Chandrayaan 3. Chandrayaan 3, the latest lunar exploration mission as part of the Chandrayaan program by the Indian Space Research Organisation, ISRO, was successfully launched from the Satish Dhawan Space Centre in Sriharikota, Andhra Pradesh, at 2:35 p.m. IST on Friday, July 14. It is the third mission in the series and shares similarities with Chandrayaan 2, consisting of a lander named Vikram and a rover named Pragyan. However, unlike Chandrayaan 2, Chandrayaan 3 does not include an orbiter. Instead, its propulsion module functions as a communication relay satellite. With a total cost of 615 crore rupees, Chandrayaan 3 is more budget-friendly compared to its predecessor, Chandrayaan 2, which had a cost of 850 crore rupees. The mission's cost savings have been achieved while maintaining its core objectives. The spacecraft is taking a circuitous route to the Moon rather than a direct path, allowing for optimized travel and reducing the need for larger rockets and excessive fuel consumption. This approach is more efficient and cost-effective. The mission's main objectives are to demonstrate a safe and soft landing on the lunar surface, showcase rover roving capabilities on the Moon, and conduct in situ scientific experiments. These investigations will focus on studying water, ice, and minerals in the uncharted south polar region of the Moon. Chandrayaan 3's final descent to the Moon's surface is planned for August 23 or 24, and it is expected to land at approximately 5:47 p.m. on August 23, 2023. This mission marks a significant milestone for India in the field of space exploration and sets the stage for future interplanetary missions. Noteworthy orbital maneuvers have been performed, including the successful orbit-raising maneuver on July 25, 2023, and the next firing, translunar injection, scheduled for August 1, 2023. Additionally, the fourth orbit-raising maneuver, earthbound perigee firing, has been successfully completed, indicating the mission's progress towards its lunar destination.